In this video, I want to take a look at some examples of hypothesis testing, specifically examples for the one mean z-test, which is the first type of hypothesis testing that we're going to look at. And I am going to walk through the steps as we go. So really the first thing we need to do is read through the problem. And so the first example reads, in a sample of 106 body temperatures with a mean of 98.2 degrees Fahrenheit, assume the mean body temperature is approximately normal with a known population standard deviation of 0.62 degrees Fahrenheit. Consider a hypothesis test that uses a 0.05 significance level to test the claim that the mean body temperature of the population is less than 98.6 degrees Fahrenheit. Okay, so the first step in the hypothesis test is to state the hypotheses. Okay, and there are two of those. You have the null hypothesis, which we represent by H sub 0, and the alternative hypothesis, which we represent by H sub A. And when you're trying to identify the hypothesis from your story or scenario, you want to look for words like claim, believe, think, conclude, because typically the phrase or the statement after those words is going to be your hypothesis. So if I look at this particular problem, near the end in the last sentence it says, test the claim, okay, that the mean body temperature is less than 98.6 degrees Fahrenheit. First of all, it says mean, okay, so we know that's our parameter. And then I see the phrase is less than, which I hope makes you think of the symbol less than, which does not contain an equal. So this particular statement happens to be your alternative hypothesis. So I now know that my alternative hypothesis is that the mean body temperature is less than 98.6 degrees Fahrenheit. Okay. And from there, I have to figure out what the null is. And what we have to remember is that the null is the exact opposite of the alternative and contains equal. So I would have the mean is greater than or equal to 98.6 degrees Fahrenheit. Now I'm going to label the one that was given in the story with a little OC so that I know that was the original claim. So I've stated my hypothesis. The second step in the process is to identify the players. Okay, so step 2 is to identify all of the pieces of information that you need. Again, I kind of use the phrase identify the players. You want to identify all the pieces of information that you need. And in this problem, you need the population mean, the population standard deviation, the sample mean, the sample size, and your significance level. There's actually another piece that we need for the calculator or for the website. For the website, we actually need the variance or the population standard deviation squared. So we'll go ahead and figure that in a minute when we get through it. So if I go back and I read through the problem, okay, the population mean comes from the hypothesis. So the population mean is our 98.6 degrees Fahrenheit. Okay. 98.6 degrees Fahrenheit. And so then I'm going to go back and kind of read through some things. Okay, it says in a sample of 106 body temperatures with a mean of 98.2 degrees Fahrenheit. The population standard deviation is 0.62, and I'm using a 0.05 significance level. Now, you could write those down as you go, but the way my screen is, I can't do that. Okay, so we go back. We now, having read through the problem, I've highlighted it. My population standard deviation is clearly stated as 0.62 degrees Fahrenheit. My sample mean was 98.2 degrees Fahrenheit. We tested 106 people, and we're using a 0.05 significance level. And all of that is given to you in the problem. In the real world, you would have gone out and collected it and had to calculate those values for yourself. Okay, when we enter our data into the website, okay, we actually ask for the variance of instead of the population standard deviation. So remember, to get the variance, you take your population standard deviation, which is 0.62, and you square it, which means you're going to multiply it times itself. And you can do that on your calculator. Okay, so I'd have 0.62 times 0.62, which gives me 0.3844. Okay, so I've identified all of the players, all of the information that I need to enter into the problem. And so then we move on to the third step. And the third step is to calculate the test statistic. For us, we're calculating a Z test statistic. We're using Z because we know the population standard deviation. That is the clue that we're going to do a Z test. Okay, so the clue that we're going to do a Z test is because we know the population standard deviation. And with that Z test, we have a corresponding p-value that the calculator is going to calculate. Remember, that's our probability value. So I'm going out to the website now, and we have to enter our information. Our population mean was 98.6 degrees Fahrenheit. It wants our population variance, so that's 0.3844. Remember, we took 0.62 and squared it. The population, the sample mean was 98.2. We tested 106 people. We had a 0.05 significance level. And the one piece where we didn't make a decision a while ago, let me go back, is we have to decide, do we have a one-tail or a two-tail test? To make the decision whether you have a one-tail or a two-tail test, you look at the symbol in the alternative hypothesis. So I'm looking at, I'm looking at the symbol in the alternative hypothesis. That symbol happens to be a less than. When I have a less than, it points to the left, and that makes it a one-tail test. It could also be referred to as a left-tail test. Okay, so on my website, I'm going to click one-tail. So I've entered all of my data. I've chosen my significance level. It's a one-tail test. And then I am going to calculate. Then I'm going to scroll down, and near the bottom in blue print, it gives me my Z-test statistic and the corresponding p-value. Even though it says less than here, we'll use an equal. Okay, so I'm going to take those numbers and I'm going to write them down. Typically, your Z-scores are rounded to two places. So I'm going to write down that my Z is negative 6.64, and the corresponding p-value is 0.00001. Okay, so I've done that. Then step 4 is to make a decision. Okay, so we're going to decide what to do. We're going to compare the p-value sorry about that, value, and alpha, that level of significance, to make a decision. And that decision is either going to be to reject the null hypothesis or fail to reject the null hypothesis. So let's do the comparison. Okay, so my p-value, which came from the calculator, is 0.00001. Alpha, which came from my problem, my significance level, is 0.05. And guys, you're going to compare these digit for digit. Okay, so if I compare the first digit of p is 0, the first digit of alpha is 0. There's no difference. Then if I compare the second digit, 0 to 5, 0 is less than 5. Therefore, p is less than alpha. And the guidelines tell me, if you go back and look at the guidelines tell me if p is less than alpha, that we should reject the null hypothesis. Then I'm ready for the fifth step. The fifth step in the process is to write your final conclusion. The final conclusion should always contain your level of significance. So typically, I start out by writing, that I would say at the 0.05 level of significance. And then let's go back up to the beginning, back to our hypotheses, and try to figure out what this means. Okay, so we initially said that we're going to reject the null hypothesis. So in this case, we are rejecting the null hypothesis. If we're rejecting the null hypothesis, that means we believe the null hypothesis is false. If the null hypothesis is false, then by default, the alternative has to be true. So we're going to basically state whatever the alternative is as our conclusion. And in this case, we would say that it's less than, okay? So I'm going to scroll down, go back. At the 0.05 level of significance, the mean body temperature of the population is less than 98.6 degrees Fahrenheit. And that's the end. Okay, that's the whole process from start to finish. All right, let's look at a second one. The second example says a survey claims that the average cost of a hotel room in Atlanta is $69.23. To test this claim, a researcher selects a sample of 30 hotel rooms and finds the average cost is $68.43. Assume the cost of a hotel room is approximately normally distributed with a population standard deviation of $3.72. At the 0.05 significance level, is there enough evidence to reject the claim that the average cost of a hotel room in Atlanta is $69.23? So again, our first step in the hypothesis process is to state the hypotheses. And again, as you think through and state these hypotheses, again, typically we have the null, which is H sub O, and the alternative is H sub A. And again, you want to look for those words like claim, believe, think. And oftentimes it's stated near the end of the problem. So again, if I'm looking at this problem, it says, reject the claim that the average cost of a hotel room in Atlanta is 69.23 degrees. Okay, so there's our claim. And the key word that I see here is the word is. I hope the word is makes you think of equal. And so that means that this particular statement happens to be your null hypothesis. So we're saying the average or the mean is $69.23. Okay, and this was the claim that was originally stated in the story. So then I have to determine what the alternative is, and the alternative is the exact opposite of the null. And so the opposite of equal would be not equal. So my alternative is that the mean does not equal $69.23. And there's our hypotheses. The second step, again, is to identify the players. Identify all of your information. And so we need to know the population mean, the population standard deviation. We need the sample mean, the sample size. We need the significance level. And then again, for the website, we do need the population variance. And we also probably need to decide if it's one-tailed or two-tailed. So again, I'm going to go back and kind of scan through the problem, and we'll highlight these particular values. It says, in a survey claims that it's a 69.23, a researcher selects a sample of 30 hotel rooms. Okay, so we're going to have 30 hotel rooms. The average cost, so my sample mean is $68.43. My population standard deviation is $3.72 and a significance level of 0.05. So again, I'm given everything in the problem. I know that my population mean is $69.23. My population standard deviation was $3.72. My sample mean was $68.43. I believe. Let me double check that. Okay, make sure we get our numbers right. Yep, $68.43. We checked 30 hotel rooms. We're using a significance level of 0.05. So again, I'm going to find my population variance by taking the sample, the population standard deviation, and squaring it. So we're going to do 3.72 times 3.72, which gives me 13.8384. And again, I'm going to go ahead and make a decision about whether I have a one-tailed test or a two-tailed test, because I know I need that for the calculator. So again, to make that decision, we look at the alternative hypothesis. In this particular problem, I have not equal. Anytime you have not equal, it is considered a two-tailed test. So we have identified all of the information that we need. So I'm ready for step 3. Step 3 is to calculate your test statistic. Okay, so we're going to do that. Okay, so step 3. Well, let's see. Step 3, we're going to calculate. Again, we're doing the z-test because we know the population standard deviation. And we're going to with that, we calculate its corresponding p-value. So I'm going out, back to my calculator. I'm going to reset it. My population mean was $69.23. My population variance was 13.8384. My sample mean was $68.43. We checked 30 hotel rooms. We're using 0.05, and it was a two-tailed test. And then I click calculate. And again, I scroll to the bottom, and I get the value of Z is negative 1.1779, and P is 0.238. Okay, so again, we typically round our Z's to 2 decimal places. So I'm going to come back and write that down. Okay, so I have Z equals negative 1.18 when you round it to 2 decimal places, and P is 0.238. Then I'm ready for step 4. Step 4 in the process is to compare P and alpha in order to make a decision, to decide whether we should reject or fail to reject. So I'm going to make that comparison. So my p-value, which comes from the calculator, is 0.238. Alpha was given in the problem as 0.05. And again, you're going to compare it digit for digit. Okay, so the first digit in P is a 2 compared to 0 and alpha. 2 is greater than 0, so P is greater than alpha. If P is greater than alpha, we fail to reject the null. Okay, that's the rule. If P is greater than alpha, fail to reject. If P is less than alpha, reject. So then we're ready for step 5, and step 5 is that we're going to write our conclusion. And again, when we write our conclusion, we typically state the significance level. So I would have at the 0.05 level of significance. Okay, then let's go back up here to the beginning and kind of think through this. We fail to reject the null. Okay, so fail. Oops, sorry about that. We fail to reject the null. If we fail to reject the null, that means the null is true. And the alternative in that case would be false. So when we state it, we're going to state it in terms of the null hypothesis, which means the cost of the hotel room that we're in Atlanta is $69.23. So we would say the mean or the average cost of a hotel room in Atlanta is $69.23. And that's it. Okay, we're going to try to walk through one more. We've done an example of the last band. We've done an example of an equal. And I want to do one more example of a question where you have a greater than. So this is our third example, and we're going to go through and read the question first. It says, an article in the Atlanta Journal stated that students in the University of Georgia system take 4.5 years on average to finish their undergraduate degrees, with a population standard deviation of 1.2. Suppose you believe that the mean time for the undergraduate degree completion is longer. You conduct a survey of 49 students and obtain a sample mean of 5.1. Test your claim at the 0.01 significance level. So again, the first step in any hypothesis test is to state the hypotheses. Again, we say H sub O and H sub A. Now, in this problem, it's maybe worded a little bit differently. You may not catch it as quickly. In the last sentence, it says to test your claim. Well, your claim was back up here in about the second sentence because it says, suppose you believe, so we got that word believe, the mean time for undergraduate degree completion is longer. Okay, so I see that word or that phrase is longer. And so I hope is longer makes you think of greater than in terms of the mathematical symbol. And because it is greater than, this is going to be your alternative. So we're saying that the mean time for undergraduate degree completion is longer than 4.5 years, which is what the article in the newspaper said. And that's our original claim. Again, we have to then figure out the null hypothesis, and we know it has to be the exact opposite, and it has to contain equal. So it's going to be the mean is less than or equal to 4.5 years. Okay, then we move on to the second step. And in the second step, we know that we want to identify the players. So I'm going to kind of go back through the problem first. It tells us we have a population standard deviation of 1.2. We did a survey of 49 students. We had a sample mean of 5.1, and it wants us to use a 0.01 significance level. So again, everything that we need is given to us in the problem. So in step 2, we're going to identify the players, if you will. And again, you need the mean, the population standard deviation, the sample mean, the sample size, alpha, and for our website, we know that we need the population variance. And so, again, I've kind of identified all those things in the story already. My population mean comes from the hypothesis, which is 4.5. My population standard deviation is given as 1.2. The sample mean was 5.1 for 49 students, and we used a 0.01 significance level. I need to find the variance, so we need to do 1.2 squared. So we do 1.2 times 1.2, which gives me 1.44. We also need to decide whether we have a one-tailed test or a two-tailed test. Again, we do that by looking at the symbol in the alternative hypothesis. This one is greater than. It's only greater than. So that is a one-tailed test. There's only one option. And to be specific, it's a right-tailed test. Then I'm ready for step 3. In step 3, we go out and we calculate our test statistic and our p-value. Okay, and again, for us, we are doing a z-test, and we're doing a z-test statistic, again, because we know the population standard deviation. Okay, so I'm going to take all of this information, and I'm going out to the website. I'm going to reset. My population mean was 4.5. My variance is 1.44. The sample mean I got was 5.1 for 49 students. I want to use a 0.01 level of significance, so I'm going to click the button next to 0.01, and it was a one-tailed test. Then we're going to calculate. And I'm going to scroll down, and it gives us a z value of 3.5 and a p value of 0.00023. So I'm going back to my paper or to my screen, and I'm going to write that information down. Okay, so I have z equals 3.5. You can add a 0 for making it two places. And the p-value is 0.00023. Okay, so that information comes directly from your calculator. Then we move to step 4. In step 4, we compare P and alpha to make a decision. Okay, so let's do that. My p-value from the calculator or computer is 0.00023. Alpha is 0.01. Again, compare it digit to digit. Okay, so I have 0 compared to 0. There's no difference. 0 compared to 1. 0 is less than 1, so P is less than alpha, which means we reject the null. Okay? Finally, I'm ready to make my final conclusion. That's step 5. And we'll begin by using our significance level. So I would write at the 0.01 significance level. And then let's go back up here and think about it. Okay, so again, in this case, we reject the null, which means the null is false, which means the alternative is true, which means your claim was valid, that it is actually longer. And so that's what we want to say. So we want to say that, let's see, how did they have it worded? On average, it takes students, let's see, at the 0.01 level of significance, it takes students on average longer than 4.5 years to complete an undergraduate degree. Now, there's various ways you can say that, but ultimately, you have to say that it takes longer because we rejected the null. And so we have to state it in terms of the alternative. Okay? So hopefully now you have an example of a less than, a greater than, as well as an equal. And so you have an example of all three types. So hopefully that'll benefit you as you're preparing for your module exam.